G'day, welcome back, Year 11. Now we are on to lesson, day 3. So typically what we plan to have been doing on Thursday. Now we're moving on to compound interest. We've been looking at simple interest for the last couple of days. Compound interest is, I would argue, a more realistic system. Well, you see it in some pretty big applications in life. Things like home loans and credit card debt, don't get a credit card. And yeah, this is a type of interest that you see more often in the real world, though you do also see simple interest in a lot of situations. Compound interest, remember there's always the two scenarios. One is you've invested money, you've got money and you want to make more money off it. The second scenario is you've got debt, you've borrowed money, for whatever reason, and you need to pay that money back. Either way, interest is involved. If you are investing your savings, you earn interest, you make interest. If you have debt, then you are paying interest for the honour of using someone else's money. Where am I getting to with this? The point is that with compound interest, the amount of interest you earn or pay is based on how much you have or don't have at that given moment in time. So if I borrowed $2,000, initially I'd be paying interest on $2,000. But if a year from now I actually owe $2,200, then I'd be paying interest on $2,200, not the initial amount. The idea with compound interest is you're always paying interest on what you currently have or what you currently owe. With simple interest, you only ever charge interest on what you initially borrowed or what you initially invested. So simple interest always based off the initial value. Compound interest is based off what you owe at any given moment in time. And so it is a bit more realistic in a lot of real life situations. Unfortunately, the formulas are slightly more complicated, but that's okay because we love mathematics. So compound interest. You earn interest on top of interest or pay interest on top of interest if you're on the wrong side of that. Right? It's calculated off the current value, not the initial value. The initial value is used in simple interest. Now, thankfully, the formulas here are as you have seen before in previous years of your education, hopefully. That's your normal compound interest formula. A equals P outside the brackets 1 plus R to the power of N. So you might be thinking, well, what the heck is all that? Right? A is your final amount. How much you owe or how much you have at the end. It's in dollars. P is the same as you've seen in simple interest. It's the principal, which is the original amount. In dollars. R here is actually the same as I in our previous simple interest situations, exactly the same. It's interest rate as a decimal. So interest rate as a decimal. And N then is the number of time units, which is also the same as the simple interest formula. Why do they use R instead of I? Why do they do that to you guys? Anyway, so N is the number of time periods. We will, of course, use that in a couple of examples later so that it doesn't look so horrible. In the textbook, they also go into the idea of recurrence relation, that the amount of debt you have or the amount of savings you have for one particular year is related to the value for the previous year. When we're looking in simple interest, it was a pure dollar amount. Each year, your amount of debt or savings was going up or down by a very fixed amount, The example I had there, I think it was about $60 each time. So each year you'd have $60 more than you had the previous year. With compound interest, you need to multiply instead of just add or subtract. So the recurrence relationship is essentially the value this year is going to be the value last year times something called R. And R they call, what do they call that? See, I haven't seen this before. R they're calling the compounding factor. And the compounding factor is simply 1 plus the interest rate, again, as a decimal. Notice how I and R are being used for the same thing, really annoying. I is the same as R, so interest rate as a decimal. Okay, so from here, guys, that's the theory, but we're going to do some good examples, don't worry. I'm going to focus more on using our traditional compound interest formula because I think this recurrent stuff is more likely to confuse matters than anything else. And you should be able to use the compound interest formula to do anything that you want to do. But if you want to see, in the text often they're saying, well, here's one way of doing it and here's another way of doing it. I'm going to show you the compound interest formula way of doing it. If you want to do it the other way, then please feel free to refer back to the text. So here we go, guys. We'll do a simpler example first. What am I up to now? Male, female, or neutral name? I don't know. All right, Sky's got a lot of money, $235,000 at 3.1% compound interest for 7 years. How much interest is earned? Right, so as normally goes at these worded questions, we need to think about what do we got and what do we want. So here we have this initial amount. So we tend to know that as P, so P is 235,000. So we've got that. We've got a interest rate there. They're always quoted in per year unless some weirdo says something different, right? So we've got 3.1. We need to convert that to a decimal, so it'll be 3.1 divided by 100. Right? And then we've got the number of years, the interest rate and the time units are in years, so it's okay. Remember, we always have to work in the same time unit. You either work in everything in years or everything in months or everything in quarters. You've got to work in the same time units. So N is 7. As we always do, the first thing we do is we quote our formula. A equals P 1 plus R to the power of N. We put in our values. To the power of N, which is 7. Now, that one definitely is going to require a calculator, guys. I have to admit, I'm not going to be doing that one in my head just now. It'd take me a little bit of time. So we put it in our calculator. Remember, your calculator is different, but if you need to do to the power of something, it's this X with a little box on it. It might be in one of your different areas there, but make sure to use that button, X to the power of, to get that to the power of 7. I can do a demo with the calculators, one of your calculators or whatnot if you want. I might need to nick one from the school, but you know, everything's possible. Not that I'd ever encourage that, don't do that. And anyway, so that gives me a final amount of 290,990 and 30 cents. So that investment, after it's been at 3.1% for 7 years, that's what it's going to be worth. So she will have that amount of money, $290,990.30 at the end of 7 years. Sometimes you'll also be asked then, well, how much interest did Sky earn? And Do you know how to calculate that? If you started with that and you ended up with that, how much interest was earned? It's just going to be that number, subtract that number. That'll give you the amount of interest, how much additional money Sky earned by having this investment. All right, so now we'll go on to a harder example. Might do one in quarters, I feel. We can do anything, but we'll work in quarters. I hope you've all taken really good notes. I'm going to clear this board now. All right. Here we go. So I need another name. What's a name? What do we... It's ridiculous. I have no feedback here. Anyway, Jack we'll do a debt one. The last one was a savings one where someone was investing their money to make money. This time we'll do a debt one where someone's been naughty. Jack has $7,406 of credit card debt. With interest compounding daily. This happens with this sort of debt. It can be compounding daily, every single day, more cents onto your debt. Compounding daily at 16.2% per annum. And yes, credit cards can also have that sort of interest rate. It's all about risk. The riskier the form of debt is for a bank, then the higher the interest rate they're going to charge you. So, credit card debt, if they don't have a house or a car they can take back off you and it's just on a card, the bank is facing a high level of risk, so they're going to charge you a much higher interest rate. All right, so at 16.2% per annum, how much will he owe in 18 months? Now, the challenge here is we've got to be working in the same time units. And the interesting thing about this is the interest is being compounded daily. Essentially, with compound interest, you need to work in the time unit that's the same as when it's compounding. So compounding daily means we must work in days, right? Work in the time unit that is the compounding. Right, compounding daily, it's all about the days. So, what do we got? It's a compound interest question. So to start with, I would hope that you are thinking of the compound interest formula. A equals P 1 plus R to the power of N. What do we got? All right, so we have the initial amount, which is P. So P is 7406. The interest rate. It's currently per year. See, this is where things get tricky. You have to convert that percentage to a decimal, so you're going to divide by 100. But you also want it to be per day. If it's 16.2% for an entire year, what's it going to be for one day? It's going to be very small. And to do that, we have to think how many days are in a year? 365, well, normally. And yeah, to divide that also by 365, we just put it on the bottom like that. I did something similar in a previous lesson we have a video for here. So that's R. And what's the other thing we need? N. Oh, that is actually going to be trickier than I planned, because the interest rate's in days. We said we had to work in days. We need that 18 months in days. That's not so nice, is it? Okay, so what I'm going to do to start with is 18 months. If you divide that by 12, you'll get it in years. I'm hoping you may or may not have noticed that 18 months is 1.5 years. If you divide by 12, you get 1.5 years. But we don't want it in years, we want it in days. Each year has 365 days, so we multiply that by 365 to get the number of days. And you'll get, well, that's kind of weird. You're going to have to round it because it's a decimal number. We can't have a decimal number of days. That's not cool. All right, it's approximately 548 days. Now, I remember in our workings in this subject last term, actually, that they were okay if we assumed 30 days in a month. So another way we could have done this is if it was 18 months and they're comfortable with assuming it's 30 days per month, you could have had a go at just going 18 times 30, assuming 30 days per month, and that would have given you 540. So I probably would have accepted that as well. If you'd done that, that's okay. All right. So let's keep going. We've now got all the values we needed to put into our equation, so let's do it. All right, P is 7406. R is this nasty looking formula. And N is 548. So part of the trick there is going to be putting that in your calculator. There's a lot of fraction things in that. So I'd go 7406 times, I need to open a bracket, 1 plus, and then I need a fraction, so I'm going to press your old friend the fraction button, 16.2 over 100 times 365, close the bracket, and to the power of, x to the power of blank, and 548 equals, and I'm getting $9,444.74. I need to have some reward if you guys pick up on any error with this too, because remember these examples are not as per the text. If I do make an error, please do let me know. Not sure exactly how I'm going to reward you from here. Maybe a review of the Hunters and Collectors back catalogue, because I know you all want to know, but I do appreciate any corrections because we are doing this on the fly. Now, that's it. That's our answer, isn't it? How much will he owe in 18 months? That's it. That's the amount. That's the final amount. That's how much Jack will owe at the end of 18 months. The other type of question leading in from that you can be asked is how much interest has he added this year? Added in that time. And if you want to look at that philosophically, remember how I said before that your final amount that you owe is going to be the initial amount you owed plus the amount of interest? Well, you can rearrange that formula if you want and realise that the amount of interest, if we subtract P from both sides, the amount of interest is always going to be the final amount subtract the principal. Now that makes sense, guys. Think about it like this. That's the amount he owes. That's the amount he owes now. That's the amount he owed at the start. What's the difference between the two? Because the difference between the two is the amount of interest, right? If he owed that and now he owes this, then the difference between the two is the amount of interest. All you need to do is go, well, he owes this amount now, take away what he owed at the start, and it will tell you how much interest he needs to pay, right? That's what that formula says. The final amount, take away the initial amount, is the amount of interest. So if you put values into that, 9,444.74, subtract 7,406, $2,038.74. Whoops. Yeah. All right. I might put that in my calculator just quickly to avoid too much serious embarrassment. Yes, that is correct. So isn't that cool? Oh, my mug's not in the way, is it? The camera's being held up by a book and a bottle of olive oil, actually. Anyway, is anyone still watching? All right, so guys, that's a harder question. So we did interest compounding daily. In the text, it has an example of one where the interest is compounding quarterly, so every quarter of a year, which is 3 months. So there's an example in there if you want to look at it. Calculate their balance after 5 years and then find each of the values and make a graph. I'm sure you all like making graphs, yes? All right. What I'm going to do next is an example where you need to rearrange the formula slightly, so another complication of the existing. I hope you've all got that down or very happy with your notes, because here we go. This will be the last bit for this content. Just going to do another example. All right, so that was a male name. I need a random female name. Emma. Emma will do. Right. Emma wants her investment to grow to $8,700 in 4 years at a 2.7% per annum. It's always per year anyway if it's not stated. Interest rate compounding quarterly. How much does she need to invest? Okay, well, this is going to be fun, isn't it? What makes this different is, we remember our compound interest formula, A equals P 1 plus R to the power of N. You're actually given some different information this time. So up here it says she wants it to grow to be $8,700. So that's the final amount. That's not P, that's not the principal, it's A. So A is 8,700. You're given an interest rate, fair enough, as is usual. Oh, it isn't usual because we're compounding quarterly, aren't we? We need to work in quarters of a year. So we do have to be careful here. So we had our 2.7% interest rate. We divide that by 100 as normal to get the decimal. But we also need to put in times 4 here because we want the interest rate for just 1 quarter. if it's 2.7% for an entire year, we need to divide it by 4 to get it for just 1/4. And by putting a times 4 on the bottom, it's the same as dividing by 4. That's the third time I've shown that trick now. So that's for an entire year. That's for only 1/4 of a year. That'll give us the interest rate for just 1/4. And the other thing we've got to be careful of then is it said for 4 years, but we need to work in quarters. How many quarters are in 4 years? It's going to be 4 times 4. There's 4 quarters in each year. Times 4, there will be 16 quarters in 4 years. Think about it. All right, so just note there, must work in quarters. But let's go back to our original problem, which was we had A, R, and N, and the question wants to know how much should she put into this in the first place. The question's actually asking us for P. What on earth are we going to do? The easiest way, I think, is to consider that what's the opposite of multiplying by all of this stuff? Dividing. We can actually rearrange this formula to make P the subject so we can find P. We essentially divide it by all of this stuff. And remember, whatever we do to one side of an equation, we have to do to both. What that'll give you is P is going to be equal to A divided by 1 plus R to the power of N. Why I like that formula is once I've got it, I can just put the values in. In the text example, I think you'll find they put the values in and then they do the same thing. You've still got to divide by that section, but they put the values in first if you want to see it done a different way. The one in the text, again, is different numbers, different scenario, but mathematically the same. All right, so in this case, let's put our values in. A was 8,700. R was 2.7 over 100 times 4, and N was 16. So again, carefully and lovingly put this into your calculator. 1 plus 2.7 over the top of 100 times 4, close bracket, to the power of 16, and you get something like that. Right, so P is 7,812 and 19 cents. So therefore 7,812.19 would need to be invested initially. All right, so there we go, guys. That's pretty well this section. They also have a section on using spreadsheets to calculate compound interest. I think we have a lesson where we're going to be looking a little bit more at Excel next week. So I'm not going to jump too much into Excel at this point. The most important thing right now is that you understand compound interest and how to calculate these things, how to calculate the amount of compound interest. And again, I cannot reiterate how important this is in life for understanding home loans and the terrible, terrible nature of credit card debt and some other traps you can get into in life. So there you go. Please have a go at the example questions. If you've got any issues, you know where I am. You can find me. Thank you.